So even if global warming is happening, if you have a La Nina-like state, it can moderate the trend of global temperature rise. What will be the impact, future projections of ENSO impact? So 21st century projections show that El Nino precipitation will intensify with more intense drying in the western Pacific and increased rainfall in the central and eastern Pacific. Also there is a situation where you might have a kind of a variation in El Nino state. I will come to that. There is a different flavor of El Nino state. That's why you can expect more rain over central Pacific than the eastern Pacific. If you have El Nino Modoki-like state, I will show you what is El Nino Modoki in a few minutes. Role of mean state I have already explained. So the mean state in the tropical Pacific might favor more La Nina-like state if it is what it is now. Some of the other models can also say that. Some of the other models say that there can be El Nino-like state. Besides that kind of decadal variations in ENSO cycle, we also have ENSO diversity, and one of them is the central Pacific like El Nino, which we call the El Nino Modoki. So El Nino Modoki is slightly different from El Nino. In this case, you can see that the wind is still blowing from the east to west, but on top of that, we also have wind blowing from the west to east. So from the eastern side, wind is blowing from east to west. On the western side, the wind is blowing from west to east. So on the western side, it looks like an El Nino state. On the eastern side, it looks like a normal La Nina state. But that together lead to El Nino Modoki state when the temperature is accumulated in the central Pacific. So temperature is warm in the central Pacific, cool in the eastern side, and cool also on the Indonesian and Philippine coast, western side. So that leads to more rainfall in the central Pacific, but usual La Nina-like state in the American side, and also usual El Nino-like state on the Philippines and Indonesian side. And that is called El Nino Modoki, which is different. As you can see, the anomalies are different in SST and also rainfall. Opposite thing happens during La Nina Modoki when the winds are like from west to east, from central Pacific to the American coast, and also east to west. So winds are diverging from the central Pacific, converging into the American coast, eastern Pacific, and Philippines and Indonesian coast on the western side of the Pacific. So we have rainfall on the eastern side, rainfall on the western side, but no rain in the central Pacific. That's the La Nina Modoki state, which is again different from La Nina. And the dynamics is something like that. So wind, as we see during El Nino Modoki years, the wind blow from west to east on the western side, but it doesn't go all the way to the eastern side of the Pacific. So most of the wind converge in the central Pacific. So the thermocline depth is deeper in the central Pacific, and then once the El Nino Modoki happens, the discharge happens, then we go back to the normal state. It doesn't completely evolve into an El Nino state. If it is El Nino, then these warm anomalies propagate all the way to the eastern side, and then after 1 year you will have the warm anomalies in the eastern Pacific. But this doesn't happen during El Nino Modoki years. The warm water gets accumulated in the central Pacific, and that's how those are different from the El Nino case. And because of the warm anomalies in the central Pacific, we have convergence. You can see that the green means higher moisture, yellow and orange means low moisture. So the eastern side has low moisture, western side has low moisture, central Pacific has high moisture. So that's why we have rainfall, and we have double Walker circulation, one on the east, one on the west, not like one Walker circulation we have seen in the El Nino case, like here. And the influence also is different. So you can see that the teleconnections are different for different regions. In this case, I'm showing you 3 examples: China, Japan, and United States of America. This is the climatological state for the boreal summer, June, July, August. You see that most part of China is wet, southern part of Japan is wet, and western coast of USA is dry usually during June, July, August. And these are the composites. The middle one here are composites for El Nino Modoki cases, and the bottom one here are the composites for the El Nino cases. So you can see that the influence is quite different between El Nino and El Nino Modoki. For the El Nino case, southern part of Japan is wetter than normal, but El Nino Modoki case, it is drier than normal. And similarly, for the west coast of USA, is usually wetter than normal during El Nino year, but it's drier than normal in El Nino Modoki year. So if you see the Philippines and Indonesian side, again during El Nino Modoki year, it will be dry, drier than normal, and also El Nino years will be drier than normal. So some regions are quite different, but some of the other regions are similar. Now, what is the future projections of ENSO Modoki? Because ENSO Modoki has its unique teleconnections compared to El Nino, so that's why we need to understand. El Nino Modokis are well predicted also in the present time, so that's why we need to understand how they are going to behave in the future. Some of the models says that unlike canonical El Nino, which typically brings droughts to Indonesia, El Nino Modoki has a more varied impact, sometimes even supporting near normal rainfall, because it's not as strong as El Nino. So El Nino Modoki influence might be lower for the Indonesian region compared to El Nino. If it is El Nino, it's completely dry. And also, if in future, as some of the models are projecting that ENSO Modoki like phenomena we should expect in the future. So if El Nino Modoki like phenomena happens more in the future, then the central Pacific will have more rain, but not the eastern Pacific. The South American coast, the western side of USA will remain dry in the future projections. If it is El Nino like state, those regions will get more rain. If it is La Nina like state, those regions will have droughts. So depending on what the future projections, we may expect very dry condition or less dry condition or even wet condition, depending on whether it will have El Nino or El Nino Modoki situations. So in summary, ENSO is the leading mode of interannual climate variability arising from coupled ocean-atmosphere interaction. We have seen that how the ocean atmosphere interact to develop ENSO. I showed you several hypotheses. Each of them have advantage and disadvantage. So we see that the Beer-Konitz theory explaining the phases of ENSO, whereas Urquist's warm water volume, discharge discharge mechanism, and also the wave dynamics explain the periodicity and aperiodicity of the ENSO, why it can happen in 1 or 2 years and why it can happen sometime in 5 and 6 years. The global impact is pretty high. Many regions are influenced by El Ninos and also La Ninas. So depending on whether you have El Nino or La Nina, some of the regions will have a high rainfall or droughts, and also leading to marine heat waves and affecting the ecosystem over land and the oceans. So if upwelling is stronger, as it happens during La Nina years, the eastern Pacific will have a better ecosystem, less heat waves, and good for the fishery in those regions. But if La Nina happens, everything shifts to the western Pacific, then we will have upwelling in the western Pacific, so better for the ecosystem there and also the fishery there. However, the eastern side will be warmer, and that will influence the fishery and ecosystems over the oceans. However, because the temperature is warmer during El Nino year on the American coasts, so they get more rainfall. So the deserts in Peru and several parts of South America get flooded, and we see ecosystem blooming during El Nino years. Now the issue is whether in the future we will have El Nino-like state or La Nina-like state. If it is El Nino-like state, then the Eastern Pacific will lose the fishery and ecosystem, but will have better land farming and agriculture. But if it is La Nina-like state, it will be good for ecosystem and fishery, but the land regions will remain dry or even drier. Predictability, we see that El Nino can be predicted easily 6 to 9 months ahead with very good skill, and by using CNN and other AI machine learning technique, we are kind of trying to extend that to 1.5 years. Now we have good skill. It's not as high as we see for the 6 to 9 months time scales, lead time scales, but nevertheless we have good skill above 0.6 up to 1.5 years ahead using AI and machine learning technique like the deep learning technique of convolutional neural network. And we hope by combining dynamical model with AI machine learning model, we'll have better skill of predicting El Nino even on longer lead times, not only predicting ENSO, but also ENSO's teleconnections to different parts of the world. Current forecasts skillfully capture event growth and peak amplitude, but struggle with onset timing, event diversity, and regional impacts, and that we hope to improve by including AI machine learning techniques in different phases of predictions by improving the data assimilations, by improving parameterizations in the model, and by improving the ensemble averaging using a different machine learning technique to give weightage to ensemble members that do better for the predictions. For the teleconnections, we still have issues because the rainfall predictions are not as accurate as temperature predictions. Those are because of parameterizations, and we hope that can improve with AI machine learning and hopefully with higher resolutions of global coupled models. Future projections remain uncertain. Some models disagrees on changes in ENSO strength, frequency, and also phases of ENSO, El Nino and La Nina, and extremes and their special patterns under warming. But we have some kind of consensus that we might have El Nino-like state depending on situation, or La Nina-like state, and depending on that, the rainfall will be different for different parts of the world. So there are still some key challenges how the future will influence, the future scenarios will evolve to influence the ENSO dynamics and ENSO periodicity in the future. I'll stop there. Thank you.